Okay, next I'm going to go through the flow solver setup. So first of all, create a flow solver. So I'm going to select this incompressible one, which is simple foam. Right, the first stage is to import the mesh. So import, there's the mesh I've just created. Import that, and straight away we can see the mesh in the background, which is perfect. Right, we've got the boundary conditions down there, so I can set those in a minute. First thing is materials, so I'm going to select water. Next one is turbulence model, K epsilon. Boundary conditions. Right, with the boundary conditions, some of these are set at wall, so I'm just going to go through and select the inlet as patch, inlet 2 as patch, outlet's already patch, and pipe is wall. So for inlet 1, I'm going to select 0 gradient pressure, velocity surface normal fixed at -1, which means 1 meter a second going in. Then for the turbulence values, fixed value, I'm going to select 0.001 and 0.01 for epsilon. I'm going to leave UT at calculated. Same for inlet 2. Total pressure, 0 gradient. Velocity, surface normal fixed. Change that -2. And for the turbulence, I'm going to select the same value as what I did last time. And calculated a new T. For the outlet, total pressure, fixed value at 0. Velocity, 0 gradient, 0 gradient, 0 gradient, and 0 gradient for everything else. I'm just going to quickly check those. Inlet 1 at -1 meter a second. Inlet 2 -2. Outlet, 0 pressure. Pipe is all the default ones for a wall. So next I'm going to initialize the flow field. You're just going to initialize it to 0 pressure, 0 velocity, and set some turbulence values which are needed. Solver settings. Just going to reduce the under relaxation factors a little bit. Okay. That's all good. Numerics, I can leave the discretization to the default values. Monitors, I'm not going to use a monitor this time. I'm just going to run that for 100 iterations and see what happens. Okay, now that that's finished running, we can see the screen output's finished 100 iterations. We can look at the monitors. And the monitors are looking good because they've converged for 100. So then we can go to show result. So this should show us the flow solution. There we are. So that's our flow solution. That's showing pressure on the pipe. So we can change that to velocity. And I need to adjust the view. So I can also change the parallel projection. I'm just going to move the legend over to the top here. So that looks okay, even though it's only done 100 iterations. It looks like we've got the right velocity going in and the right velocity going in the secondary inlet. So now I just want to have a look at a cut plane. So I'm going to select cut plane on the top left, Z normal, and apply. And I need to select that to U velocity, and that looks really good. So you can see the mixing, the high speed flow going in there and then mixing, which looks really good. I can look at the pressure, I can look at the turbulence, I look at the eddy viscosity. So that all looks good. Okay, so now I've rerun that solution. Instead of 100 iterations, I've ran it for 1,000. And looking at the residuals here, you can see that it looks pretty much converged after about 600 iterations. So we can go to the flow solution again, and that's the converged flow solution at a cut plane. And we can also have a look at, say, the eddy viscosity and see how that has how that's developed. So that's about it really. That is a converged flow solution, and from there you can download the results to your local machine if you want to, or you can just leave it there on the dicehub website.